Alright, so when you look at this particular example, you see that the man is pulling this wire, right? A cable, whatever. So you see there's only one force, right? And then when we're trying to get a resultant, we have to get the vertical component and then the horizontal component. These are just two, right? But there could be cases where it could be as this form, right? Let's say you're having a force P, and a force S, and a force Q, right? And then the the aim is to find a resultant force, right? So let's say you're having a particle. This is just an example. A force acting at it this way, another force acting at this way, right, and this way. And then we want to know whether the particle, if after all these forces have been applied, that's what we call the resultant, the effective force that will be on the particle, whether it will allow this particular particle to stay or to continue to move or whatever. It will depend on the resultant force, right? And then when it comes to this case where there are more than one forces, right, and then we want to know the resultant force, we do what we call the sum of the x and then the y component, or the component of the force, right? So then for this one example, like this will happen. So you see, we just remember that because they are in 2D, right, the forces here are in 2D, meaning that they are planar, they all lie in the same plane, right? So then, so it still holds. We have our coordinate system, right, this way, x, negative x, here's y, and then here's negative y, right? So then when you align, even if you can decide to put it in it, but like you can decide to still leave it out, it's still the same thing, but you just have to visualize it and know where they are, right? So you know that if you are trying to get a resultant force for this particular case, what happened is that for all the x component, sorry, the horizontal component, you add them, or the vertical component, you add them, right, before we get a resultant force, right? So in this case, looking at the p, let's do it individually. Looking at how the p is, the the s component of the p, or the resultant component of it, will be positive, right? For the p, the y component of it will be what? Positive, right? Then we go to s, right? For the s, the s component of it will be what? Negative, right? Let's write this off. These are individual steps that I'm taking to make sure that we really get the concept right. But the moment to get this concept, you can just go straight forward to whatever they are trying to do, right? For the y component of the s, right, what will it be? It will be positive, right? And then a q is here, right? For the q, the s component of it will be positive, right? And for the q again, the y component of it will be negative. This is the first thing, right? But you can just go straight forward and find each and every one, like find all the x's, find all the y's, and add them, and then get a resultant, right? But still the same thing. Yeah. So you see the same thing here. These are just two forces, right? This one is here. Actually, this is just one force, right? And we are trying to get the vertical component and then the horizontal component, right? So you see this is the same thing here. P, right? We are resolving to get the vertical, horizontal, right? Q, vertical, horizontal. S, you see, vertical, horizontal, right? So you see, it actually makes sense. It aligns with what we've written here. For the P, you see that it's up here, aligns with the Y, right? So the Y component is positive, right? Looking at the X, it's positive, right? For the S, where's the S? This is the S component, you see, negative. The Y component, positive, right? For the Q, there's it. The Y component is negative. S component positive, right? So the direction, very important. Direction is very important, right? Very, very important, because it's statics. A change in direction could mean something else, could mean that the whole system is not balanced. Are we okay? So then there's an example. This is saying that four forces acting on the boat are shown, determine the resultant force, right? So then again, you have the force. To do something like this, you don't have to draw the table, but you have to know that to get a resultant force, because there are more than one forces, find all the x component, find all the y component, and then help you get the magnitude of the resultant. Are we okay? So that's what we do. You can go to the table later, but let's do this individually and see what's happening. So now we are trying to do the x side, right? So if I take f1, at times it's also nice to follow how they've written it, the numbers they've used, the identification, to make your work easier. So now we are doing the s component, right? I think the s component for f1, right? All the way. So looking at f1, what will be the direction of the x? It will be positive, right? Because the coordinate system very important, very important. The moment you have the coordinate system in mind, whatever that you do, you get the direction right. Are you okay? So it's very nice to have the coordinate system in mind. You don't necessarily have to draw it as we are doing here all the time. Here's y positive, here's y negative. Are you okay? So looking at this one for the f1, right? You see that the x component is positive, so just positive, right? And then we have the force, where is it? 150, right? And then we want this side, the x component, the adjacent side, so we use cos, right? So cos of 30, right? So, and then we want f2, right? F2, the x component, what is it? This f2, right? We want the x component. So looking at the what do you call it? The x component of it, will it be positive or negative? Negative, right? Because of this negative here in this direction, so negative, right? The magnitude of the force is for 18, right? And then we want the x component, right? The adjacent side. There's one thing we must look at again. Here's the case where we want the x, right? The x is what we are looking for. When we come back to this one, you see that we're looking for the x, which is this side, and that angle is actually, this angle here is directly on this side, right? So this is the adjacent side relative to this angle, right? But when you come here, see the angle is here, but what we are looking for is here. It's not this side. We want the x, right? So what do we need? We need the opposite side, because this side here, we can trace it to come here and to be opposite to this angle. So it's no longer cos but sine. Okay, this is one thing to do I must notice. Okay, we'll go over that one shortly, but let's see what will happen. So right, analyze component, we have 3x, right? 3x f 3x, yeah, what is it? So there's it, right? Looking at this force, it's just straight. So will it have a what do you call it, an x component, a horizontal component? No, because the angle is what? 0, right? Relative to the horizontal, the angle is 90, right? So the magnitude of the force, the x component of this f3 will go 0. Are you okay? So here's 0 newtons, irrespective of direction, right? It can be positive or negative, it doesn't matter, because it's 0, it doesn't change anything, right? And then f4 x, this f4, right? Looking at it, the x component will it be positive or negative? So you see it's here on this one, right? Because this is the origin here. Let's do this. This is the origin, right? So positive x, positive about this. This is what I'm doing. Alright, so the f4x, right? We want the horizontal component. So here we know it's positive because of this, right? So yeah, so direction is positive, right? And then the force is 100. Then again, you don't have to go through all this thing every time. You just have to get the concept and go straight for it. I'll be okay. Yeah. And then the angle is 15, right? And then this is the angle, and this is the side I want. It's adjacent to this angle, right? So cos, right? So here's a case where you have to break the general conception of the sine and cos, that the cos is for the x and the sine is for the y. No. So that's 15 degrees, right? So that's what we get. So 1, 2, 3, 4. The forces are 4, right? So we have all the s components. So let's see. Let's try and do the computations and see what we are getting. Direction very important, and then getting to know whether to use sine or cos, right? Then it can be confusing, but if you are good with that already, I think it's fine. Yeah, so f1x, that's all, 150 cos 30. And for this stuff, it's nice if you have the things in 2dp, but generally 2dp, but at most there are times where whoever is want you to solve the problem or the question, so will have a particular requirement that make it 4dp or something, so just follow. Okay, and at times it's even written at the front side of the paper, the question paper. just to know. But if nothing is given, 2dp is the worst case scenario, like at least 2dp, you'll be fine. This newtons, right? And then what's the name? F2x. That's minus the signs are very important, because if you change the sign, it's a whole new story. Okay. Yeah, is that 20? F2. Yeah, 20 degrees. So negative 1 to negative 27.36 Newton, and then 3. And you see how it's flowing when you do it this way, like you get everything and you just go straight to your calculator and punch everything. It would have even be better if we had just done the y component too and do everything straight. It makes your work easier instead of going to calculator and coming back and stuff. So f4x, right? So that's 100 cos 15, right? And that's giving us 96.59. And you see how the calculator was lagging to give us the answers. At times the memory is loaded, so you can clear it. This is just, by the way, just to make it work faster. Let's see, we have all of them. So the resultant x that we are looking for, yeah, so we get the rx, this resultant, then all the x, right? We get all these by adding everything here, so that'll be the answer that we are getting here. Wait, let's do this manual. 129.90, and then 27. Whatever you have there, even the signs and negative, bring everything. That way is cool. 0, no add it. No, 96.59. The fact that we didn't add a 0 doesn't mean that whenever you see a 0, you don't add it. Even if, let's say if it's 0.07, add it, we beg. For the sake of accuracy. But this one is just for 0, that's why I'm omitting it. So this is what we have for the x, right? 199.16 newtons, right? Now the y component. Right, so we are doing the y component, right? So then again, one by one, to make your work easier, or you can do everything at once, right? Or x at once or y at once. So now we are doing the y at once. Okay, so that's f1 y, right? Looking at, so then again, our reference is this way, right? Right, this here. This is x, this is negative x, this is negative y, right? And then we'll have y here, right? This is our origin. Where the axis meet is our origin, right? And then comparing to the diagram, this is our origin. So when you have this in mind, the direction, you will never skip the direction, you will never miss the direction. Okay. So now looking at the f1y, all will be positive, right? So positive, right? The magnitude of the force is 150, right? And then we want the y component, the angle is here, right? So it will be opposite side, which will come here, sine, right? Sine what? 30 degrees, right? And then we have y2 y, right? What is y2? Sorry, f2, right? This f2. Looking at what it is, the y will it be positive or negative here, right? It's still up here, so positive, right? The force is what? 80 degrees, right? So general way is the direction, whether negative or positive, right? So let's see, the y component is like this, whether negative or positive, and then we have the full force itself, right? And then we have either sine or cos, right? So sine or cos angle, right? This sine or cos depend on what we are looking for, right? So now f2, we have the direction, right? Positive, right? And then we have the force, which is 80 newtons, right? And I want the direction, we want the y, right? Is the y our interest is the y. Looking at how it is, if this is the angle, this is the hypotenuse, the y that we are looking for will be here, right? So it's actually the adjacent to the angle, so 20. So the adjacent mean that we'll be using what cos, right? Yes, cos of 20. f3y, right? Looking at f3y, the y component is here, negative, right? So that's it. Negative, right? And then the magnitude of the force is the 410 because it's lying just along the y-axis, right? The angle there is the angle to the y-axis is 0. It's actually on the y-axis. They're in the same direction. So we write the full force 110, right? It doesn't make an angle with it, so that's write the 410. And then F4, right? F4. F4y. F4y, right? Looking at F4, all the YB, the y will be here, negative, right? The magnitude of the force is 400, right? And then the angle that it makes is 15, right? But here's the case, what are we looking for? We are looking for this, right? But the angle, this is the angle is here, right? The F4 angle is here. So if we are looking for this is not adjacent to this angle, for it to be here, fine, but now it's here. So if it's here, it means it's opposite, right? So we use what? Sine. Sine what? 15. Let's see, it's 15. It's 15. 15. Right. So now let's see what we are getting for our resultant y. Let's see. So this here, this here, this here, this here, right? So this is still the 110 minus 110 newtons, right? F1 will be 150, right? 150 sine 30. All that give us. Yeah, so then again, when you have problems like this, you can clear your calculator. Yeah, just to make it fast. Yeah, times it as this. So 75 newtons. 75 newtons, right? And then F2y. That's all. 80 cos 20, right? 75 again. Then again, you can do two decimal place to make your work easier. There's a way to even do it on the calculator straightforward, right? Yeah, so you can follow that one. It is F3. Yeah, it's still minus 110. So minus very important, should be there. F4, what do we have? Minus 100 sine 15, right? Let's see what I get in. Minus 25.88 newtons. So now you're adding them up. So that the sign should be there. 25. Sorry, everything should be there. Minus 25.88, right? There's 4.3 minus what? 110, right? And then we have a plus 75.88. 18, right? And then we have so minus 25.80 minus 110, and then plus 75.18, and then we have 75, right? So this is what happened, and then we get 14.30 newtons, right? So now that we have these two, the resultant, the x component of it, and the y component of it, this is what we'll try to do. Now the question is like we should find what the resultant of the forces, right? So meaning that they just want the magnitude. The only thing of interest here is the magnitude. So this is what we'll do. We just use this to find the full resultant. This is what we need: square root of the rx squared plus ry squared. Then again, when you change them, they are the same thing. It doesn't matter. Ry squared plus rx squared, right? This is the same thing. Let's see what we are getting. Let's see. Okay, this is what we have. So square root of right. And most of the times it's best to avoid any mistake. You know the formula you're using. it's better to point the formula in first and then move back and then put everything there, right? So 199.16, and what do we have for the y? We have 14.30, right? This is what we are getting. Resultant is 199.67 newtons, right? So let's see if we are on the right path. Yeah, so it's safe to most of the time do it this way. You do the x, y, and then you combine everything to see what you are getting. So what did they get? The magnitude of the force. Yeah, so it's actually very close. Where is it? Yeah, it's very close. 199.67 newtons, right? So now this is giving us the what's the name? The magnitude of the force. Then because it's a force, when we are trying to find resultant force, so we are trying to fully describe a force, you need magnitude and direction, right? But here's the case where we have only the magnitude, right? So what we can do, because as a resultant force, it will on its own, if we are to draw it, it will have its own magnitude and direction, right? And then because this x component and y component of it are actually aligned with the s axis and the y axis, so like natural sense, we sound like this, right? And this is the resultant force, right? So meaning that we can assume it to be some sort of triangle, right? And then we can do this to get a triangle. So we have this and then we have this, right? So that's what we can get. We can tan of the angle here, if it's alpha, is equal to opposite of our hypotenuse, right? Sorry, opposite of our adjacent. What is the opposite? The opposite is ry and the adjacent is rx, right? So you get the alpha by doing tan inverse, right? And then we'll get ry on this rx. That's what gives us that. So let's see what we are getting. So most of the time it's good to know where you are going so that you have your procedure set already. That way you are fine. You can just go straight, knowing what you need to get what you want, right? You know you have everything already. So where's ry? That's 14.3, right? And then x is what is it? X 199.16, right? Yeah, so this is what we have. So we end up getting our alpha to be 4.1. Most of the times when it comes to angles, we usually make them whole numbers, right? So yeah, so it can be this 4 degrees basically, right? So the full description of the force, resultant force is the magnitude 199.67 newtons, and then add the angle, right? 4 degrees. Okay. And then when you're trying to do this angle stuff, it's very important that you have everything in degrees, right? Because if it happens that you have anything either radian or gradient, you get different stuff, right? So let's be in degrees. Okay. So everything here will be in degrees. Yes, so that's what's happening. Let's see if we are on the right path. Yeah, so we are on the right path. Yeah. So in actual sense, this is how it will be, right? The whole thing will tend to this: the resultant force, y component, s component, right? And then the angle here is, well, they are 4.1 there, so you see. So you can just write the 4.1 or just, yeah. So to be on the safer side, 2 dp at least at all. Okay. Yes. Alright.